Okay, let's move on to the third method. This is nothing but use of partial fractions to obtain inverse Laplace transform. Okay. Use of partial fractions. So we can express phi of s, which can be sum of any quadratic or linear function, as partial fractions. How? Phi of s will be expressed as a on s plus a the whole raised to r plus bs plus c upon s square plus a square in the whole raised to r. Okay, so this is nothing but expressing phi of s in terms of partial fractions. Okay, phi of s is nothing but what? Laplace of f of t. Yes, phi of s. So what we do? We express phi of s, which is nothing but Laplace of f of t, in terms of partial fractions, and then after that we apply standard functions to get answers. So okay, so this will be the third method to find inverse Laplace transform. So let's take an example. So we'll understand how to first find partial fractions. Suppose if I want to find Laplace inverse of s plus 29 upon s plus 4 into s square plus 9. Okay, so partial fractions, how will I understand? Yes, this is third method. I have to use partial fractions. See, whatever it is given in the question, so it will be in terms of multiplication of either a linear or a quadratic term, or multiplication of two quadratic terms, or multiplication of two linear terms. So this is what multiplication of a linear term and a quadratic term, right? So I'll understand. I have to use partial fractions. So linear term will express like this, and quadratic terms will express like this. Okay, so what this will be, let's say first consider s plus 29 upon s plus 4 into s square plus 9. So how will I express this in terms of partial fractions? As a upon s plus a the whole raised to r. So s plus a is what? Linear term is what? S plus 4. So a upon s plus 4 plus bs plus c upon quadratic term is what? S square plus a square. So here it is s square plus 9, right? So what this will be? S plus 29 will be equal to a into s square plus 9 cross multiply. Okay, plus bs plus c into s plus 4. This is upon s plus 4 into s square plus 9. Okay, s plus 4 into s square plus 9, right? So denominator is same. I can equate the numerators. So s plus 29 will be what? A s square plus 9a, right? I opened up the bracket. A s square plus a s square plus 9a, okay, plus bs square plus 4bs, bs square plus 4bs plus c into s plus 4c, right? C, just open up the bracket. Okay, okay, so equate. So this will be what? This is s square, this is s square, so this will be a plus b into s square. Okay, 4bs and plus cs. So this will be what? Plus 4b plus c into s. Okay, a plus b into s square, 4b plus c into s plus 9a plus 4c. Okay, just got all the same terms together, s square with s square, s with s, and constants. Okay, so this all like terms. So s square term, here is no s square term, which is nothing but what? 0 s square, right? So what I have? A plus b will be equal to 0. Since s square is not here, s square, so coefficient will be 0. So a plus b equal to 0. S is what? 4, S has coefficient on the RHS 4b plus C, and here it is what? 1, right? So one more equation I got is 4b plus C, which is nothing but 1. 29, right? Constant, and 9a plus 4c equals 29. Okay, just equate RHS with LHS. Okay, so what I get? A plus B, S square, no S square term, so 0. 4b plus C, S term, and coefficient is 1, so 1. 29, which is nothing but constant, and your constant on RHS is 9a plus 4c. Okay, so if you solve these three equations, which can be easily solved in a calculator, okay, scientific calculator in equations. So what I have, I get A as 1, B as -1, and C as 5. Okay, so if I solve these three equations, I get A as 1, B as -1, and C as 5. So I'll just put this back here. Okay, so what I have, put this here. So what I have, A is what? A I got as 1, so this will be 1 upon S plus 4, right? Plus B S plus C. B I got as -1 into S, right? Plus C I got as 5. So 5 upon S square plus 9, right? So A is what? 1 upon S plus 4. B is -1, so -1 into S, okay, S, right? -1 into S, which is nothing but -S, plus 5. 5 is nothing but C. 5 upon S square plus 9. Okay, so I have this. So okay, so this was the way you solve partial fractions. Now you are there with the partial fractions. So I have now 1 upon S plus 4. See, this is minus S. So I'll take minus common in order to make S positive. So this will become S minus 5. Okay, to minus common. So S minus 5 upon S square plus 9. So this is nothing but this. I just took minus common. Okay, so we got in standard form, right? 1 upon S plus 4 minus S minus 5 upon S square plus 9. So what this will be? So Laplace inverse of S plus 29 upon S plus 4 into S square plus 9 will be nothing but Laplace inverse of this, right? 1 upon S plus 4 minus Laplace inverse of S upon S square plus 9. Okay, this minus and this minus again will be plus 5 upon, write it down, plus Laplace inverse of 5 upon S square plus 9. I just open this up. Okay, so three terms. First term, Laplace inverse of 1 upon S plus 4 minus Laplace inverse of S upon S square plus 9. Minus into minus is nothing but plus Laplace inverse of 5 upon S square plus 9. Right? So these are nothing but standard functions. So 1 upon S plus 4 is nothing but 1 upon S plus A. So e raised to minus at. For the first term, we use S plus 4. So e raised to minus at. So A is what? 4. So this will give me e raised to minus 4t. Right? Laplace inverse of S upon S square plus 9. S upon S square plus 9 is cos at. Okay? Cos at. So A is what? A is nothing but, A for this is nothing but 3. Right? So this will be minus cos 3t. Right? And for this, 5 upon S square plus 9. So nothing but 5 into 1 upon S square plus 9. 1 upon S square plus A square. So A is nothing but 3 square, 9, right? So for this also A is 3. So this is what? 1 upon A sine of at. So 5 by A is 3 into sine 3t. Okay, so this will be nothing but your final answer. S plus 29 upon S plus 4 into S square plus 9. Right? So this is nothing but your final answer. So what we did, we had this. We had to find Laplace inverse of S plus 29 upon S plus 4 into S square plus 9. So we understood, yes, this is a problem based on partial fractions. Partial fractions. Why partial fractions? Because the question had multiplication of two terms, which is nothing but one linear term and another is quadratic term. So we express this in terms of partial fractions like this. Okay. we expressed in terms of partial fractions, right? Partial fractions, we got the values of A, B and C as 1, -1 and 5, right? After that, this came into standard form. We use standard formulae to obtain the final answer, okay? So this is the way you will solve sums based on partial fractions.